In this video, we're attempting a definite integral of x squared tangent x on the interval -1 to 1. And I actually made this thing intentionally so that there is no symbolic antiderivative for that function, x squared tangent x. And the whole point of the problem is to look at a symmetry perspective on this function. So when I look at that function x squared, that's an even function. And that means it has symmetry about the y-axis. And the algebraic test for that is if I replace x with -x, I just get back a copy of the original function. Now right next to that is the tangent function. And the tangent function is odd. That means it has a rotational symmetry of 180 degrees about the origin. And you may just remember that the tangent function is odd based on how you remember the graph of it. Or you may have to think of it as sine divided by cosine, and then you remember sine is an odd function, cosine is an even function, and if I divide an odd and even function, I get an odd function. And if you have no idea what I'm talking about with this even and odd stuff, I'll just be posting links at the top of this video to my review of even and odd functions and products and quotients of even and odd functions. All right, so the whole point is that we know an even function times an odd function actually yields another odd function. So this whole thing is going to have 180-degree rotational symmetry about the origin, and that means at a glance, I can tell this integral is going to vanish. Because with an odd function integrated on a symmetric interval, we were going from -1 to +1, whatever negative area you have on one side is going to be exactly canceled by whatever positive area you have on the other. So keep an eye out for these things. This is a huge deal in physics and engineering. You end up with a lot of integrals that have symmetric integration intervals, and it's considered part of ordinary mathematical fluency to be able to throw out all the integrals that are zero just at a glance. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.